Hi, this is Patel. In this lecture, we are going to look at the numericals based on the principal stresses. We have studied the principal stress concept in the previous lectures, and using those concepts, we are going to solve this type of numericals or practical applications. So let's get started with the basic numerical first, and then we will see a little bit more advanced numerical. So the numerical data is on your screen. As you can see, the principal stress at a point are 80 Newton per mm square and 40 Newton per mm square, both being tensile. Find the normal, tangential and resultant stress across the plane through the point inclined at 80 degree to the plane having 80 Newton per mm square stress. So here they have clearly mentioned that we need to find out the normal tangential stresses on the plane which is inclined 50 degree to the plane having 80 Newton per mm square. So they have not given any figure. So we can make this diagram on our own. So we have made this diagram. As you can see, we have taken two stresses. Given stresses are considered as a direct stress or the principal stress. So first of all, they have given 80 Newton per mm square, and the second one as a 40 Newton per mm square. So we have taken 80 as in this direction and 40 in this direction. So the plane which is having the 80 Newton per mm square is this plane, or we can say that it's a vertical plane. So with the vertical line, the angle of the inclined plane should be theta, or theta is given as a 50 degree. So we have represented EF with angle theta with vertical like this. So this is the pictorial representation of our given data. We have listed our given data down. Some students might get confused that they have mentioned the principal stress, then why we have used the notation sigma 1 and sigma 2. So let me clear here that whenever a body is subjected to any type of a stresses, whether it is a principal stress or the direct stress, both are the same. So those direct stress which is due to the application of the external force or external practical condition, then it is represented by sigma 1. If we are finding the principal stresses, then we will utilize the notation sigma n1 and sigma n2, that based on the applied stresses. So right now we have denoted it as a sigma 1 and sigma 2. Later on, here they have not mentioned any shear stress. So by default we have taken shear stress as a 0. Shear stress is taken as 0 because it is not given. Theta is 50 degree. Now we will require to find out the normal stress, tangential stress and resultant stress on the inclined plane. So for that we are going to use those formula of normal stress formula, tangential stress formula and resultant stress formula. So as you can see, we have a normal stress formula, that is sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 2 by 2 cos 2 theta plus tau sine 2 theta. This is our basic formula of normal stress. We have the value of sigma 1 and sigma 2, but first we need to check our sign convention. So which sign convention we are going to use? First of all, we are going to consider bigger value as a sigma 1. So this is our bigger value 80 that we have considered as a sigma 1. Always we will keep it as a positive. Now if the second force is similar, second stress is similar, then we will consider it as a positive, and if it is opposite, then it is negative. So as we can see, both the stresses are similar, tensile. If the sigma 1 is tangential and sigma 2 is given as a compressive, then we would consider sigma 2 as a negative. But right now both are similar, that's why sigma 1 and sigma 2 both are considered as a positive. But remember this thing, whenever a student forget to apply the sign convention, they will get the wrong answer after the calculation. Even after simplifying and using the same formula, they will get the wrong answer. So make sure you are applying the sign convention before starting the calculations. So we have used those sign convention, we have inserted all the values here, all over here, and then by simplifying using the calculator, you are going to get this answer: sigma n equals to 56.53 Newton per mm square. The nature of this stress is also tensile. Why is it so? Because we are getting the answer as a positive. If we are getting the answer negative, then we will consider it as a compressive. Now, similarly, we are going to find out the tangential stress using the equation of tangential stress. We have already seen this equation in our previous session. Applying all the values and using calculator, we will get the answer of the tangential stress as a sigma t equals to 19.170 Newton per mm square. Similarly, we are going to calculate the resultant stress sigma r using this formula. Putting the value of sigma n and sigma t into this equation and simplifying, you will get the answer of sigma r as 59.86 Newton per mm square. So this is how we have calculated very simple and basic example. Now we will move forward and solve another example so that you guys can understand another method of solving. So here is your data. Find out the stress acting on an oblique section AF in the rectangular elemental ABCD as shown in a figure. So in this example, they have provided a figure. So let me provide you a figure also. So this is the figure of ABCD, and you need to find out the stresses on the oblique section AF. Here the oblique section AF is represented like this. This is A and this one is F. So AF is here. Also can find out the principal planes and principal stresses analytically. So here they have specified that we need to find out the principal planes and principal stresses analytically separately. So we will consider the given stress values as the sigma 1, sigma 2 values. So this will be our sigma 1, this will be our sigma 2. Both are tensile, so both will be taken as positive. This is our shear stress. Shear stress is cornering in this way, that's why shear stress is also positive. Now this is our reference, and from the reference it is measured angle 15 degree that is provided in our diagram. So we will apply the sign convention to that, and that's why as this angle is measured in anti-clockwise direction from the reference vertical, that's why it is considered as a minus 15 degree. So as you can see, this sign convention is very important. You will have to apply the sign convention before solving the example. So we already listed out the values of sigma 1, sigma 2 and tau. So this is the general stress condition. Now we will apply the sigma n formula to solve the normal stress acting on the AF plane. So for the AF plane, consider the theta as a minus 15. Put the value in this equation. This will be minus 30. This also will be minus 30. And calculating in the calculator, we will get the answer as a sigma n, that is equals to 264.95 Newton per mm square. This is the answer for the normal stress. As this answer is a positive, we will consider it as a tensile nature. Now sigma t. Sigma t is tangential stress, and we already know this formula of sigma t. Putting all the values into this equation, we are getting here the answer as a negative. So as this answer is negative, it is considered as a compressive. Now we will move forward to find out the resultant stress. Resultant stress can be calculated using this formula. In this equation, if you put all the value, then you will get the answer of 277 Newton per mm square. Now they have asked us to find out the principal stresses. And we know that there are two basic principal stresses. The first one is the major and the second one is the minor. There is only one difference between all these two stresses, this sign. So first of all, we will consider the positive sign and then we will consider the negative sign in order to find out both the principal stresses. So first one is the major principal stress. Using this formula and putting all the value into this formula, we will get the answer as a 315.14 Newton per mm square. This is positive, that's why we have considered it as a tensile. Similarly, using the similar equation, except this sign, putting all the value, we will get the answer of the minor principal stress sigma n2. Later on, they also asked us to locate the principal plane. We need to locate the principal plane. In order to locate them, we need to find out the angle of principal plane. So the angle can be calculated using the formula tan 2 alpha 1 or tan 2 theta 1. Based on different books, you can use the notation alpha 1 or theta 1. 2 tau upon sigma 1 minus sigma 2. Put all the values into this equation, we will get the answer as a 0.66. Now take tan inverse and you will get the 2 alpha 1 equals to this. Now make sure that you divide the given answer by 2, because this is the answer of 2 alpha 1. We need only alpha 1. So alpha 1 is equals to 16.83 degree. So this is the angle of major principal plane from reference vertical line. So from reference, if you go 16.83 degree, then you will get the answer of major principal plane. You will get the location of major principal plane. In order to find out the location of minor principal plane, see, you will use this equation, that is alpha 2 equals to alpha 1 plus 90. Now we know that alpha 1 is 16.83. Using this formula, we will get the alpha 2 value as 106.83 degree. So this is the location of minor principal plane. This is how we complete our example over here. These examples are explained and solved using the analytical method. But these examples can also be solved using the graphical method. Graphical method is nothing but the Mohr circle method. So in the upcoming chapter, we are going to look at the Mohr circle or the graphical method to solve the principal stress based examples. So we conclude our lecture as well as our chapter over here. Till then, thank you.